Here we have geometry, geometric and spatial reasoning, standard 4.4. Looking at some vocabulary here, congruent is a word that you hear many times in geometry that means the same size and shape. Okay, in this instance, if we're talking about segments, we're talking about the same length. If we're talking about angles, we're talking about the same measure. Supplementary are angles that add up to 180 degrees. Okay, so those important definitions that you will see repeatedly. A linear pair are two adjacent angles that together make a line. So adjacent is they share a vertex, share a side, and don't overlap. And between them, they make a line. Vertical angles can be thought of informally as opposite angles in an X shape. So looking at illustration, we have this with four angles. The linear pair would be angle 1 and 2. So notice the angles 1 and 2 are adjacent. And together, they form a straight line. 2 and 3, 3 and 4, and 1 and 4 are also linear pair. Linear pairs are supplementary, which makes sense because we already know that a straight angle or a line measures 180 degrees. Vertical angles we have this X shape or two crossing lines. They're opposite, so 1 and 3 and 2 and 4 are vertical angles. Vertical angles are congruent. And if you think about it, and part of this standard says to prove that, we won't make a formal proof in this slideshow, but you can make an informal proof by saying that if two angles, let's just use 1 and 3 here, 1 and 4 add to 180, but so does 3 and 4. Okay, so if two angles add to the same angle to make 180, that must mean they're equal to each other. Okay, so 1 and 3 are congruent, as are 2 and 4. An example here, let's look for x and y. We'll go for x first. So notice that when we're doing this, we can't put x and y in the same equation if we only have one equation. So let's ignore this angle, and let's go for these two. These two are a linear pair. Okay, they're adjacent angles that form a straight line. So that means they're supplementary. So I take the angle measure here and add it to the angle measure there, and total 180. Do some algebra, combine like terms, makes 46, subtract 46 on both sides, divide by 2. So the value of x is 67. If I go for the y, this time we'll forget the x. Notice that these angles are vertical angles. Okay, so they're congruent to one another. I can simply set them equal to each other and subtract 23 to get 40. Okay, so linear pairs and vertical angles, you're going to see those a lot in geometry. Perpendicular bisector is a line that is perpendicular to and bisects a segment. A fact is every point on the perpendicular bisector is equidistant from the endpoints of the segment it bisects. Okay, so here's an example of a perpendicular bisector. We know that line WX bisects and is perpendicular to YZ based on the markings. Okay, you can see the perpendicular mark, and you can see the congruent marks here. It can be shown pretty easily with a side angle side pattern that all the corresponding parts must be equal. Therefore, these distances, WZ and WY, are the same. Even though they're not marked, we have sufficient evidence to conclude they're the same because they're any point on the perpendicular bisector is equidistant from the endpoints. Okay, so we're looking for distance WZ. We know WZ is equal to WY. So we set those expressions equal to one another. Now here, the best move, since both sides are cleaned up, is to subtract 2x on both sides. So 4x minus 2x is 2x. I left the 11 and left the negative 5. Now let's add 5 to both sides and divide by 2. Okay, so x is 8. The question asks for length WZ, however. To find WZ, you insert 8 into the x position on WZ. So that would be 2 times 8 plus 11. Okay, that's 16 plus 11 or 27. The theorem says to prove and apply theorems about lines and angles to solve problems.